So now we're going to read about Newton's laws. We are used to seeing motion everywhere, and it is easy to take for granted. But if you consider the bigger picture, you can see how motion might be mysterious. What causes the planets to move around the sun? How does Earth rotate on its axis? How are these planetary motions similar to the motions we see and take for granted here on Earth? In order to survive, people needed to understand how various heavenly bodies moved across the sky so they would know when to start planting or harvesting. Sailors needed to read the changing night sky like a map to safely navigate the oceans. Survival was dependent on understanding and predicting how things moved in the heavens and on Earth. Trying to find some system of guiding rules for understanding motion was something that scholars struggled with for centuries. In the 1600s, a physicist and mathematician named Isaac Newton proposed some seemingly straightforward laws based on the work of others as well as evidence he had collected. These laws were able to explain motion on Earth and in space. This changed the way many people at the time understood motion in a dramatic way. A scientific law is a statement that describes a cause and effect relationship in the universe and is based on repeated experimental observations. Scientific laws are descriptions of observable phenomena. They don't explain why something happens. However, scientific laws can be used to make predictions about the outcomes of something. Within his elegant laws, Newton was able to describe motion in a manner that remains useful to engineers, astronomers, and other problem solvers today. You may already be familiar with the phrase, "an object in motion tends to stay in motion." This phrase is related to Newton's first law, which describes the effect of balanced and unbalanced forces on the motion of an object. According to Newton's first law, if the forces on an object at rest are balanced so that the net force is zero, the object will stay at rest. If the forces on a moving object are balanced, the object will continue moving in the same direction at the same speed. If the forces on an object are unbalanced, the net force will cause a change in the object's speed and a change in its direction, or both. The ease with which an object can change its motion is known as an object's inertia. Newton's first law can also be called the law of inertia. Newton's second law describes the mathematical relationship between factors important in predicting an object's motion. According to Newton's second law, the acceleration of an object is equal to the net force of the object on the object divided by the object's mass. So acceleration also equals the net force divided by its mass. The figures on the previous page illustrates these laws. Notice that for an object to change its motion, the net force acting on the object must not be zero. This means that the forces are unbalanced and that the object will move in the direction of the strongest force. In contrast, any times the forces acting on an object are balanced, then the net force is zero and the object does not move. And there are also some pictures here that kind of show you that. So this is Newton's first law of motion, where if it's balanced, it remains at rest. And when it's unbalanced, that's when it begins to move. And then this also shows like the change of speed and direction. And this picture goes with Newton's second law of motion, which is showing that when you put a stronger force, there's going to be a greater acceleration. If it's the same mass, it's going to be a weaker force. It's going to create smaller acceleration. But if there's more mass, then the acceleration is going to slow down a little bit, versus if there's less mass or less weight, there's going to be a greater acceleration.